Destini Petitt is the chairperson on the Brevard Sustainability Council in Brevard, North Carolina. Her PhD is in infrastructure and environmental systems from UNC Charlotte, and her recent research has focused on the human dimensions of water usage. Destini, thank you so much for taking the time today.
Yeah, thank you for inviting me to do this. This is going to be exciting conversation about my favorite topic, water.
Awesome. Well, I'd love to start with that topic of water quality and ask you how do land use changes impact water quality?
Yeah, so this is a really great starter question, and specifically because of the term land use. I use this term a lot, and the more I've used it, the more I realize that a lot of people don't truly understand what it means, what is land use, and what are land use changes. Because people think, in my experience, people think that land use is just what an urban environment looks like. And when we're talking about land use changes, we're talking about going from something that looks like what my Zoom background is here to an urban type of environment. So we're thinking about switching over a natural system into a system that looks like a small downtown or into a suburb type system or even into like a downtown metro area looking type system, right? And so that's what we're talking about when we're talking about land use changes, switching from something that's natural into something that is human and built up environments, right? And anytime anytime humans come into this picture, that's when we start to see issues when it comes to water quality, right? So we take an example like the picture in my background here, and we put in a large suburb development, right? So a lot of problems are going to come from that. So the first problem is that we're not going to have much exposed soil anymore, right? So anytime it rains, it's going to rain on top of that built up environment, those houses, those rooftops, those pavements, and that rain is not going to be able to soak into the soil, right? It's going to go down a storm drain. It's going to use what we call gray infrastructure, and that gray infrastructure is going to take all of that water and instantly channel it into the stream. Okay, so there's two problems there. One, the rain that's falling from the sky can no longer hit the soil and what we call infiltrate through the soil column and percolate really slowly into our groundwater, which ultimately feeds our streams. It's not going to do that anymore. And it needs to do that. Those water droplets need to go through the soil in order to be high water quality, right? So if you're thinking about yourself as a little water droplet, you're just going to fall in a natural environment. You're going to hit the soil and you're going to slowly sink into the soil, flow through the soil into the stream, and then go out to an ocean somewhere, right? But again, we add those impervious surfaces, those rooftops, those roadways, those cars. Your little raindrop self is going to hit one of those, flow into a stormwater drain and get channeled really, really quickly to the stream. And you're not going to have a chance to flow through what we call the subsurface and to go through chemical processing, right? And so we see an increase in things like harmful algae blooms in our waterways when we have these impervious surfaces added. We see lots and lots of erosion happening because of the energy flowing with those raindrops through all of that great infrastructure, really, really highly degrading our streams, right? And so we're thinking a lot now when we're thinking about water quality and land use, we're thinking about that difference between what's natural and now this urban development, right? But there is a whole middle section that's there that is what has happened in our recent past is going from these natural environments into agricultural environments. Specifically, when we think about North Carolina, that was kind of the first land use transition that North Carolina saw, and a lot of the states in the United States saw, right? Where we switched from natural lands into these agricultural lands. When we did that, what we saw is a lot of straightening of our channels. And with the straightening of those channels, you increase the energy, right? The amount of energy that can flow through the channel. is going to increase, which means that water is going to flow really, really, really quickly out of the channel and isn't going to be able to stay in the stream long enough to process. So when we switched from natural landscapes into agricultural landscapes, we straightened our stream channels and we added a bunch of fertilizers and pesticides onto those fields. And then that water, as it washed off into the streams, exited our watersheds really, really quickly and was not able to stay in the watershed and in the ground long enough to undergo processing and to take out those excess nutrients. Then we build up upon those and add those urban developments we started with talking with, and we have a recipe for water quality disaster. So historical channelization of our streams, the water is just flowing really, really quickly through them because there's no meanders to slow the flow of that water down. And then we build up upon it. We add all of this extra impervious surface, and that allows for that water to enter the stream even faster. The stream is already channelized, so it's just flow, flow, flow. And our streams are full of contamination because of this systematic process
Hmm.
happening over really long periods of time. And so, yes, we have changed the land a lot of times from forested to agricultural, and now from agricultural into urban and suburban landscapes, which are just further exacerbating any kind of water quality problems that have been there for a long time.
Yeah. So not only are we picking up the contaminants and the chemicals from, for example, you said the agricultural stuff, but we're also not benefiting from the ecosystem service that filters things before getting to water. So is that accurate that there's that all that those two things together are causing major water quality problems?
Oh, yes, definitely, right? Because what you mentioned, ecosystem services, right? Those are the things that the ecosystem would do without us, right? That provide us the ability to live in a place, right? One ecosystem service is the ability of plants and trees to hold on to soil with their root system so erosion doesn't happen. Another ecosystem service is when it rains, right, those roots becoming pathways for those raindrops to infiltrate into the soil and to undergo biogeochemical processing, and to purify that water as it exits the subsurface and enters any kind of stream or any other kind of area where it's going to exit that subsurface and become surface water flow. But yeah, so we have manipulated and we have changed the ability of our ecosystems to provide us with those life-changing ecosystem services. We've definitely reduced their ability to do that.
Yeah. So the next question I have is on watershed restoration and thinking about how we can deal with some of these problems that you described. How does watershed restoration impact groundwater storage, and how do you think about that?
Yeah, so going back to like this idea of historically taking our natural environments, turning them into agricultural fields, channelizing, right? So straightening those streams so that water is able to get out of that area as fast as possible, right? So that reduces how much flooding is going to happen. Okay. Then adding on top of that landscape, all of this impervious surface allows for this process called incision to occur. So incision is a bad thing. In a natural stream, there should be a balance between erosion and what we call aggradation. So erosion is, right, taking away soil, and aggradation is the ability of that soil to be built back up, right? So in a natural stream, before any of those land use changes have happened, there should be a balance between the energy of the water eroding soil from the bank and the channel itself and the curve, the sinuosity of those streams to slow that water back down so that those particles that have been eroded upstream are able to participate out of the water column, right? So if we have these straightened channels, we have energy, right? The energy of the water molecules is flowing really, really quickly, which means that a lot of erosion can occur, right? So we're getting a ton of erosion coupled with a lot of rain being funneled through stormwater pipes, leading to even more energy, right, being dissipated in the stream. So more and more and more and more erosion happens. Okay. So when we have those things coupled together, what happens is that the channel banks themselves become heavily scoured and eroded, and the bed of the channel is the next place that becomes eroded, right? So we have a typical channel that could look like this, and with erosion, we get the channel, it widens out, and then it lowers down the bank, the bed of the stream lowers down, okay? So the picture behind me is actually from my dissertation study site. So the stream that you see behind me, you'd be able to easily step into it from the banks, right? You just step from the bank, you walk into the stream, the water is basically halfway up your calf, okay? Before restoration took place, this stream, the actual elevation of the water was about 10 foot lower than what you see in the picture,
Wow.
because this was historically agricultural and it drains a really large housing development. So all of those processes I've talked about happen in this picture, right? And so when that happens, right, we have that lower stream elevation, then the thing that's feeding it, which is all of the water that's underneath the ground, right? All of this groundwater is feeding this stream and a lot of our streams throughout the United States, right? And so if that stream channel itself is really, really low, right, then all of that groundwater is draining out really, really quickly into that stream and leaving the watershed. Okay. So with my dissertation, I looked at, well, what happens if we go back in and we take that super, super incised stream and we fill it, we backfill it, and we bring the elevation of that channel back up to the surface, the same area where it can actually access that floodplain again, right? So what would that do, right? If the channel, when it's really, really low, acts as a drain for all of the groundwater, well, what happens if we're able to fill that area back up with soil? Then are we going to be able to increase the storage of groundwater in the area, right?
Hmm.
And the answer is yes. So if we go back in and we restore all of those streams that are super in size, right? Their elevation is down here. We bring that elevation back up where that stream is now on the surface, easily able to access the floodplain. Then all of that soil area that used to be draining into the stream becomes saturated again. Okay. And that saturated area, yes, it's going to still be adding to the flow of the stream, but since the stream isn't so low anymore, it's no longer a drain. It's not acting like a drain in your bathtub. It's able to hold and store more water now throughout our watersheds that are restored. So
Hmm.
this is a really big thing to think about, especially in areas that have historically had a bunch of agriculture followed by urbanization, and we have really incised streams, right? We know now, based on this research, that if we are able to restore those streams, we can increase how much storage of groundwater is there, which is important in states like North Carolina, where estimates are about 35 to 45% of households use private drinking water wells. So they're
Wow.
tapping into this groundwater resource directly, right? But it's also really important when we think about um, other places that are getting water from the surface, right, from our streams and from our rivers. If we have such an incised stream and all of that groundwater is drained out, then during a prolonged drought, a river might dry up and then a whole town might be out of drinking water, right?
Yeah.
That's probably not going to happen right now or the next decade in North Carolina, but that could potentially happen in other places in the United States and globally.
Yeah. Well, you mentioned the like the roots of trees help with erosion control. Um, I was also going to ask you about native plants, but just generally, what is the role of plants and trees in this process and an ecosystem health and resilience?
I love plants, so as part of my other things that I do, I'm like a serial volunteer. I tell people this all the time. I'm on like 100 different boards, but I'm also a chair of the local Native Plant Society, and I know like just enough about native plants to get myself in trouble. But I am a huge, huge, huge advocate for native plants because native plants are adapted to grow in the conditions you want them to grow in, right? A lot of times I see people like, well, why doesn't this Asiatic lily grow very well? Yeah, probably because we're not in Asia, right? But native plants are awesome, and super super great at helping the entire ecosystem function, right? So one of those ecosystem services we just talked about was their roots holding on to the soil. We want that to happen so we can limit how much erosion is happening in our watersheds, right? Another one we talked about is the ability of rain droplets to follow those roots into the soil to help purification of the water, right? We need those roots in order for that to happen. Another thing that we can think about when it comes to plants is plants actually provide a protective cover for the soil itself, right? So again, put your little raindrop hat on and think of yourself as a raindrop. You're falling from the upper atmosphere down to the ground and you're going to hit with a ton of force, right? And if you hit bare soil, you're going to compact that soil, right? And compaction of soil is very bad because if your soil is too compacted, there isn't any pore space for that raindrop to get into the soil itself, right? And so with our plants are there, even if it's just a grass, if that raindrop hits that grass is going to slow that energy down and then might bend over and the droplet's going to fall off the end of it in a nice, less impactful way, right? So that's another service that these plants provide us, right? We can also think about away from the stream, even though the stream is the best thing ever, right? Native plants are food for our native pollinators, right? If we don't have pollinators, we don't have flowers. We don't have flowers. Primary productivity cease to exist. Humanity is gone, right? So we need our native plants. We need these ecosystems to function in order for our life to exist, right? And I think that's important, right? Humans want humans to continue existing, right? Even though nature would be fine without us, right? Nature has a plan. Nature can function without us, right? But the other really, really important part of this plant conversation is plants, they when they die, right, they fall in the ground and they decay. And as they break down slowly, they provide nutrients to these ecosystems, right? So they provide nutrients to the floodplain, they provide nutrients into the streams themselves. And we need those nutrients again for life to exist, right? Without this cycle happening, we get into lots of trouble, right? So it's really, really important to protect all of these types of ecosystems again, right? So that we can continue existing and the ecosystem itself can continue existing.
Yeah. Well, you mentioned your different roles, like being on in the Native Plant Society, and also your role as a chairperson of the Brevard Sustainability Council. I wonder if you could talk for a little bit about how you think about the role of individuals in this work, the role of policy, and also the role of businesses, and how different in different roles we can help in this process of restoration and ecosystem health and resilience.
Yeah, I love this because it truly is not just a one sector to solve every problem, right? It has to be a collective action in order to protect our pollinators, to protect our streams, to protect our groundwater. It has to be collective action. And the reality is that action starts with the individual, right? Individuals, I know it's hard, especially when we are always faced with issues like the problems with recycling, the problems with overconsumption. It's really hard to see and understand that one action does make a difference, but it truly does, right? Because when one person does an action and they communicate that action to others, it starts a chain of actions, right? But someone always has to take that first step, right? So when I'm thinking about individuals, I'm thinking about those people that are property owners or people that know somebody that's a property owner or someone that exists, right? Those people that exist can make better landscape choices, right? So homeowners can opt to buy and use native plants. This can be really hard, especially if you're just going to big box stores, right? So my recommendation for homeowners trying to make better landscape choices is look up your local native plant society. Every single state within the United States has a native plant society. Most of them, it's only $25 per year to join, and most places have a chapter that meets every single month, right? And those chapters will help you learn what's right for your local ecosystem. And those chapters also have lists of nurseries that grow native plants, right? So that's a huge, huge thing, right? There's all kinds of native plants out there that homeowners and landscape architects or anybody, right, can go and buy and put into the landscape, right? We could go on and on about water use, right? Always limit your water use, even if you're in a water rich place like I'm here in Western North Carolina. We're in a temperate rainforest. We get a ton of rain, but it's still important to limit your water usage whenever you can, because guess what? Even if you're in the mountains of Western North Carolina, that water needs to make it all the way to the French Broad. The French Broad drains into the Mississippi River, and that goes to the Gulf of Mexico, right? So we have all of that connection that's there. So limit your water use. That's a huge, huge thing because somebody downstream of you probably needs it. um, and then anytime you can talk to other people about conservation practices or anything that's more sustainable is awesome. Another thing that I like to do is I like to do like the little landscape certification plaques. So native plant societies have them, the World Wildlife Fund has them, Monarch Byways have them. So you can get these little plaques and put them around your property, and your neighbor's like, "Hey, what's that?" And then you could talk to them about it, right? Then we move into like policymakers, and the best thing there, vote, right? So that's your individual action into the policy making action. Vote for the people that have ideas that you like, right? Vote for those people that want to protect the environment, want to protect those sensitive areas, and advocate for those spaces. Every single person that's going to watch this video lives close to some place that's sensitive, whether it be a wetland, insert ecosystem here, everybody lives somewhere close to something that needs to be protected. So being able to advocate for that using your votes and using your voice is super, super important, and helping to make sure that our policymakers understand that while there might be county lines, nature doesn't care about that. Nature doesn't care about counties. Nature doesn't care about state lines. Nature doesn't care about national boundaries, right? There needs to be like this holistic view of nature in order for any solution to work, right? And then if we think about like the business owners, um, buy things. This is another individual action. Buy things from businesses that support your ideas, right? Buy things from people that actually put sustainability into practice and don't just preach about it, right? And yes, that does require you to do a little bit of research, but that research will help you make better purchases, that actually make a difference. I will just say really quickly that um, so I'm a vegetarian for ethical reasons, and so I always try to buy products with like the cruelty-free logo on them, right? But guess what? There are false labels. So if you're going to buy based on just like a cruelty-free logo or an organic logo, you have to educate yourself on what those proper logos look like because there are lies out there. This is what we call the sin of false labeling, that people will put a logo on something just to get you to buy it, even though it might not be a true logo, right? But if you're thinking about purchasing things, right, that could be a step that you can make. Um, Also buy local. I think that goes like without saying. So if you want to support the ecosystem, buy from people that are local that are going to keep the local economy going. The local economy is where differences happen, right? So being able to support those businesses that also support local things is super, super important. One big business is, and this is not a sponsorship for them, but here in Brevard, we have Gaia Herbs. Gaia Herbs is like this global organization. They have a huge farm here in Brevard, and they are 100% sustainable. Like they do every single great practice, and they're a really cool organization that supports local, does really, really ethical things with all of their farm workers, and it's just a great organization. So finding places like that that you can support that also, right, are supporting local is really great.
So, just as kind of a question to tie everything together, what do you think the future of this work in terms of restoration and improving water quality and improving ecosystem health and resilience? What do you think the future of this work looks like, and the future of maybe the research as well?
Yeah, so I think the future of this work is going to look differently depending on where you're at, right? Where you are currently located. Here, like I mentioned, in Western North Carolina, we just had Hurricane Helene, September 27th. It was a Thursday. And Hurricane Helene decimated a ton of our streams, right? Decimated entire communities, and completely reset the balance on the ecosystem, right? And so here in Western North Carolina and like Western Tennessee, right? The conversation is different than if you're in West Texas, right? But all of the places, no matter what they've been faced with right now, the future is going to have to look like what we call integrated management, right? So, where we're looking at, again, not just looking at a county or an individual stream, but looking at how that stream influences the larger geographical area throughout that county into the next county, across state lines, and ultimately across national borders, right? We're going to start having those conversations um, in order to advance the streams and to protect our streams and ecosystems the best we can, right? Because if you think about it, if someone in the middle of Tennessee does a small stream restoration on the French Broad, but nobody upstream does anything, then that middle section, that restoration, yes, it might be a little helpful, right? But eventually enough pollution is going to come downstream to totally negate what they did, right?
Mm.
So we really need that communication across county, state, and national borders in order to truly have a difference. And I will say that one species in particular has seen benefits of this, and that's the monarch butterfly. So the monarch goes from Mexico into the United States up to Canada, and through collaboration between all of us, right, we have seen some increases in the numbers. And yeah, those numbers dip and rise depending on the year, but that's been a success story for this idea of integrated management, right? Looking across lines to help something. I really do think that that is going to be the future, um, and also thinking about um, education wise, right? We really need the general public to understand the importance of what they do, and also to understand the amazing impact that they can have if they do those things right. And I'm a huge advocate for what we call informal education. So just giving talks and letting people like show up to them and really, telling people like, what is a nature-based solution to the problem you have, right? Oh, you have a problem with stormwater. Well, how can we fix that with native plants? How can we fix that with just reshaping the soil a little bit and then adding native plants on top of it? What are the things that we can do that add nature back into your environment, that ultimately help downstream and further, right? So the future is collective individual actions, right? Individual people understanding their impact and also understanding what the solution is and how they can move forward. Um, and then if we think about science and like research, this is the thing that I love. I love thinking about multiple different disciplines and how those things come together, right?
Mm.
So kind of have a weird background where I have a bachelor's in wildlife, a master's in natural resources, and a PhD in infrastructure and environmental systems, and they've all been about water, but with each of those, I've gained like a different perspective on this water use. So my wildlife was totally like, okay, ecology, what is happening in the ecosystem? My master's, while it was in natural resources, was all about how individual people have personal values and how they use those personal values to reason about
Mm,
water usage, right? And then my PhD, when I was doing that, I was in a group of people. I had colleagues in my classes that were designing buildings, right? And how can we design buildings better where they're more efficient? And maybe how can we design windows better where birds don't crash into them, right?
mm,
But also, how can we do stream restoration where it doesn't influence the integrity of bridges and the pylons that are in the stream, right? That's the future. It's going to be cross disciplinary collaboration, thinking about how these ecosystems work. It's right. It's not just an engineering solution. It's not just adding concrete to the stream. Yeah, it works where it works, and I have a beef with engineers, so it's
mm,
okay. They know that. It's adding that, right? It's adding that combination of the built environment with those nature-based solutions from a holistic, multi-watershed, multi-state, multi-country perspective that's going to get us to an ecosystem that is resilient for the climate change we've already enacted and
mhm.
that will be there for future generations and be there to ensure that those ecosystem services continue long term, right? So that's the cool thing is being able to take a step back and think about this from so many different perspectives. That's what we're going to have to do in order to move this science forward, right? Because we've found out a lot of things and we know a lot of things. Now it's just how do all of these things fit together?
Yeah. Well, Destiny, thank you so much for taking the time to share your insight and your wisdom. I really enjoyed the conversation, and I hope we can continue the conversation down the road.
Yeah, definitely. Thanks for having me, and I love water.
Awesome.